Okay, so a spinner is to be divided equally into 8 numbered sectors and is spun 20 times. So there are 20 trials here. The table below shows the number of times the arrow landed on each sector. What is the empirical probability that the spinner will land on a prime number on the next spin? So empirical probability is probability based on data, and it's always the number of successes or whatever you're looking for as the numerator. In this case, it is the ways to land on a prime number it's always out of the total trials. So here we know it's going to be out of 20 because they told us it's, excuse me, they told me there are 20 trials here. So what's the probability of landing on a prime? Well, 1 is not a prime, right? 1 is identity. 2 is prime. That happened 3 times. So there's 3 chances of getting 2. 3 is prime. There are 2 chances of getting that. 5 is prime. Sorry, allergies. And 7 is prime, right? Prime numbers have 2 factors, 1 of themselves. 4, 6, and 8 are all even, so they're not prime, right? So X is there, sorry. Okay, so we just have to simply count these up and we've got the answer, right? So there are 3 ways to get a 2, put a 3 up here, plus the 2 ways to get a 3, plus the 4 ways to get a 5, plus the 3 ways to get a 7. So that's 5 plus 7 or 12. So it's 12 out of 20. That's your probability of getting a prime number on the next spin. Okay. Here, what are we told? There's a square dartboard, and the side of the square dartboard is 40 inches. Okay, I'll show that here. Shaded portion has a side of 15 inches. A dart thrown on the board is equally likely to land on any point. Find the probability of a dart hitting the board that will not land in the shaded area. So they want to know what's the probability that will land right in this region around the shaded area. So we have to first of all realize that our total area is 40 squared. Right, that's the total area of this dartboard. And if we subtract the shaded region from the total area, so if we take 40 squared and subtract 15 squared from it, that will be the shaded region, right? What do they call it? The not shaded region, right? Because it's the entire area, or subtracted, but the shaded region. So not shaded area. And the probability is just the ratio of what you want to get, in this case not the shaded area, out of the total. So what we're going to solve here is 40 squared minus 15 squared out of 40 squared, right? So here, the calculator, 40 squared, of course, is like 16 squared, but, 40 squared is like 4 squared, but 100 times larger, right? And that we're subtracting 15 squared, or 225 from that. Okay, we get 1375 divided by 40 squared, or divided by 1600, is 0.859375. Okay, so the probability is times it by 100 is 85. Sorry, go back. 0.9375%. And they tell us they don't say round, so we'll leave it as this right here. So anyway, that makes sense. It's more likely that you would hit the non-shaded area than the shaded area itself, because the shaded area is so small. Here we have a spinner, and they want to know what's the least likely to occur. An odd number. Well, the probability of getting an odd is 1, 2, 3 out of 6. So it's 1/2. A prime number, well, 1 is not prime, but 2 is prime, 3 is prime, and 5 is prime. So that's 3 out of 6, or 1/2. So those are both equal, so it can't be, neither of them could be the answer. We're trying to find the least likely. A perfect square is a number that has a perfect square root. In this case, there's only 2 of them, 1 and 4, because the square root of 1 is just 1. If it was a decimal square root, it wouldn't be a perfect square. And the square root of 4 is, of course, 2. So that is, those are 2 out of 6, or 1/3, right? So that's less than 1/2, okay? So that looks like it could be it. A number divisible by 2. Well, 2 is divisible by 2, and so is 4 and 6, so that's also 1/2. So the answer is 3, a perfect square. There are only 3 numbers that are perfect squares with perfect roots. how many different ways can 5 books be arranged on a shelf? So if it was 5 books or 5 numbers, it would just be 5 factorial, or 5 times 4 times 3 times 2 times 1, which is choice 4. Okay, so this person they're trying to make an outfit, it says, and they have a t-shirt, blouse, and sweater for tops, jeans, skirt, capris for bottoms, flip-flops, and sneakers for their feet. Okay, list the sample space or draw a tree diagram to represent all possible outfits. So we're going to multiply this 3 by 3 by 2, or 18. And I'm going to use a tree diagram because it helps me keep track of all this. So first we can have a t-shirt, a blouse, or a sweater. You pick a t-shirt, right? You can have jeans, a skirt, or capris. And if you pick t-shirt and jeans, you can still get flip-flops and sneakers. And we just keep going. Flip-flops, sneakers, flip-flops, and sneakers. You can draw all of this in, but I'm going to kind of jump ahead because here we have 2, 4, 6 options for just the t-shirt. And then for the blouse, we'd have another 6. And for the sweater, we have another 6. We'd have 18. So 18 combinations. So they want to know how many outfits contains jeans and flip-flops. Well, we can count, right? So if you start with a t-shirt, here's the flip-flops. Oh, they want flip-flops and jeans, sorry. So here when you have jeans, you have to also have flip-flops, right? Those two have to be together. It doesn't happen here or here. But that'll happen once, right, in each of the situations. It'll happen when you start with a t-shirt, it'll happen start with a blouse, and it'll happen with shoes. So that's out of 18. That'll be 3 out of 18, which of course is a 1/6 chance. Determine how many different outfits do not include a sweater. Well, a sweater is one of the basic tops that you pick. So this right here represents the sweater, and everything from there will also have a sweater in it. That's a total of 6 combinations, so it's 18 minus 6, the total minus the 6 with the sweater, which is 12.